All right, I'm Jason Compton. I'm the producer of Falconbridge Players' presentation of The Blue Comet, a play by Eden Phillpotts that has never before been seen in this country. And I'm joined by Anthony Taylor. And Anthony, I'll let you give your credentials, but you are our resident comet and asteroid and celestial body expert.
Hello, I'm Anthony Taylor. I'm currently a fifth-year PhD student in astronomy here at the University of Wisconsin Madison. And I did a bit of my undergrad work at Harvard University, where I worked with Dr. Martin Elvis on doing some work with asteroid tracking and even a little bit of asteroid mining. So when Jason approached me to talk about this play involving a comet, it's a little not necessarily directly on my wheelhouse, but certainly in the ballpark.
Yeah, and The Blue Comet is a play about the disruption in a middle-class English household as a comet is on what everybody believes to be a collision course with Earth. And we see things play out over the span of about 2 months as the comet gets closer and closer, and the scientists are surer and surer that it's going to crash into the Atlantic Ocean. Just to back up a little bit, how much do we know about what would happen if a comet really did smack into the Earth? I mean, is this a thing that has happened in living memory and in human civilization? What's kind of the background on this?
Yeah, so in terms of comet impacts, to my knowledge, we've never seen any of those hit throughout human civilization. Asteroids, of course, we get impacts all the time. Of course, they're very, very small objects, say only 1 to 2, 3 to 4 meters across. If we're talking about something like a comet that we, be able to visibly see in the night sky with the naked eye, I don't think we've ever seen anything like that hit. And certainly that'd be more akin to something like the asteroid that might have wiped out the dinosaurs than anything that we see hit Earth nowadays.
When I asked you to do some math on, so just what would this mean, you decided to use as a representative a real comet to simulate some of the effects that are described in the play. Can you tell us a little bit about what you chose and why?
Yeah, so I went with Halley's Comet. Now, there's a number of comets that we know of and track diligently, but Halley's is the one that really is a household name. It's the one people have heard of, and it's the one that we really have the most data on. So I thought that was a nice representative sample to be both an example of a comet, but also an example of a famous comet, something that could be akin to something as impactful as something in the play.
Yeah. And just for putting it in perspective, how big or small is Halley's Comet compared to something like the moon?
Yeah, so Halley's Comet is roughly 11 kilometers across. The moon, on the other hand, is going to be about 3,400 kilometers across. So while Halley's Comet is, a large object, even as many of the asteroids are concerned, there are objects that get much, much larger, much, much more quickly in the solar system, and our moon is absolutely one of them.
Okay, and that are certainly whipping around the planet all the time, and we seem to be doing okay with it. So that may come up, may come up a little bit later. This play, like I said, was first written and performed in the late 1920s. I should be specific here. And Halley's Comet, like you said, it's a big cultural touchstone. I'm old enough to have been a kid when Halley's Comet most recently visited, and I can attest it. Halley mania was definitely a thing. Did some research, can see that it was definitely a thing in 1910. That was quite a bit before this play came out, though. Do you have any sense what 17 years later might have sparked Eden Phillpotts to think, yeah, there's definitely an audience here for a play about a giant comet heading towards Earth?
Events like this tend to stick in the public mind, so I think it absolutely could have lasted that long. But also, I think that astronomy in general tends to be something that's very accessible to write about, because all you really need to do is look up. You look up, you see your stars, you see your planets. So I think it's something that's always very present to a lot of people. And so I think it's always something that's rather timely to put into literature, playwrights, movies, etc.
it seems like that period of time was a pretty fertile period for making discoveries about the solar system. We're actually still a few years away from Pluto being locked down and definitively identified. So was the 1920s just kind of a big period in general for interest in astronomy?
I like to think that the interest in astronomy has constantly been growing, really as technology's grown. So as we're getting better and better telescopes, larger telescopes, we're starting to see fainter and fainter objects in less time. And especially as we approach the 20s, that's when we start seeing a takeoff of computing power as well. This is where the analog computers are starting to gain a little bit of traction. And so that makes, especially some of the computations, even the ones mentioned in the play, start becoming a lot more feasible. And so you can start moving away from what one might consider traditional astronomy and really start moving into almost astrophysics and even sort of the start of astrocomputation. And so I think that it's only really snowballed from there with digital computers. And now astronomy, at least my job, is almost entirely data-driven. I'm looking at a picture of the sky, but for me, it's a big grid of numbers that I'm going to manipulate to try to pull data from it. As the technology is improving, especially in the 20s, you're starting to get astronomy and really space science generally starting to become a lot more accessible. And I think that can very much keep this sort of intrigue, again, in the public eye and especially in the eyes of the scientists.
Now, the characters that we see in the play are not scientists. They're not astrophysicists. One is a book collector. One is a painter. One raises chickens. One's a retired military officer. So these are not the people that are studying the comet. They're just learning about it in the newspaper. They're looking up into the night sky and seeing this unusual object that shouldn't be there as it gets larger and larger. And so we see the characters take their different personal approaches that reflects their values on what this comet means to them. Some see it as a sign from God. Others are just sort of very fatalistic about it in a non-religious way. And one of the conversations that comes up between a couple of the characters is about the objective scientific potential, and it's really interesting. This play was premiered in Birmingham, England, performed in London, England. Eden Phillpotts is a Brit, never performed in the U.S., but America, as represented by Chicago, which I find very interesting. They always refer to America as Chicago. They say, well, Chicago's trying to capture the comet and use it as a source of energy. There's a line, it's up to science to catch it and collar it or shoo it off before it gets nasty. America's spoiling to catch him. There's enough energy in the brute to run the world for 1,000 years. So that's maybe the first science test question for you. Is there validity to that? Is there validity to either what chemically composes a comet, or if you were able to somehow corral it in orbit and have it whip around, that it could be some reliable, tangible source of energy for productive human use?
When you posed this question to me offline before we started, I ran a bit of math on this. And my first question was, well, how much energy would we actually need to capture it in the first place? And so I did a rough model using Halley's Comet moving, admittedly faster than Halley ever moved, but as the play stated, at about 500,000 miles per hour. And if we wanted to capture it, say, at about 400 kilometers above the Earth's surface, so the height of the International Space Station, how much energy would we need to put in to slow it down enough such that it would actually stick in a stable orbit around Earth? The number wound up being about 7 times 10 to the 24 joules, or about 10,000 times the annual energy consumption of Earth. So that's the energy you would need to put a collar or a harness on it, as they said in the script. The question then becomes, how can you extract energy from it? And that really becomes sort of the tricky part, because once you have an object orbiting, all of its energy really is coming from that orbit, so the velocity it has that keeps it in orbit. So if you want to extract energy, then you need to slow it down somehow. And that's sort of where I hit a dead end, because anything I could think of as slowing it down is going to require us needing to spend energy to slow it down. Mm-hmm. So I'm not quite sure how you'd be able to extract energy from something in orbit, at least not directly.
But there's something to the indirect nature, because like tidal energy, which is provided indirectly by the moon. I mean, that gets captured and turned into, electricity, and there's more direct ways. If you put a boat, you put a boat on the
Certainly.
ocean, you take it somewhere, you can kind of track that back to the moon. But it sounds like the juice not worth the squeeze on a Halley's Comet type object.
I wouldn't put my money in it.
Okay, so maybe slight exaggeration when the play goes on to say there's enough energy in the beggar to heat our houses, light our streets, run our railways and motor cars and airplanes, and do all the driving and fighting work of the world for about 1,000 years. Not so much?
Well, I'd say you got probably 10 to 20,000, but you just can't get to it.
Okay. When the third act begins, we're 30 minutes away from impact. The stage directions mention that the comet is huge in the sky, and you were telling me before we began that you modeled what it would mean to have a Halley's Comet type object get close enough to be that big in the sky and then miss. Now, Phillpotts talks about the societal impacts. He has the characters, muse about like, wow, what's this going to mean to all those people who spent all their money because they didn't think there was a tomorrow? What's the birth rate going to be like? Because obviously that's how a lot of people have been spending their time. But he doesn't get into the any atmospheric disturbances or seismic or tidal disturbances. What would happen if a comet buzzed us that closely?
Yeah, so that closely is really the key phrase here, and how close is that close will very much change what the results are. So if we go to the most extreme example without involving the atmosphere, because as soon as you involve the atmosphere, things get very, very messy very, very quickly. So if we let Halley's Comet, for example, pass by at what we call the Kármán line, so the line that is roughly agreed to be the edge of space and the edge of our atmosphere, then at the time of closest approach, Halley's Comet would actually appear about 12 times larger than the moon in the sky, so it's 12 times wider. And the question then becomes, my first thought, as was yours, was what would be the tidal effects on this? So I crunched the numbers quickly, and it turns out at that distance and at Halley's mass relative to the moon's mass, it'd be influencing the tides at about 4% of what the moon does. That's not insignificant. That's a real number there. The issue is how long it would be doing that for. And at the speed given, it'd be producing that amount of pull for about maybe half a second before it would be missing the Earth, flying by, and the further it moves away from us, the weaker and weaker the gravitational force that it exerts on the Earth and the Earth's oceans would be. So you'd certainly get a pull on the Earth's oceans, but I'm not entirely sure whether that would cause tidal waves or not. It's because it's going to be a tug, but it'll be a smooth pull on and then a smooth let off. So unlike something like an earthquake where you have an entire tectonic plate shifting and displacing water to create a tidal wave, in this case, you're getting a much smoother grab and release. So I would definitely think a planetary scientist might be able to answer that better than I could, but I don't think it'd be as cataclysmic as even some of the tidal waves we've seen from earthquakes are. Now, of course, if we get a little bit closer and we have it start rubbing on the atmosphere, then things get a lot messier and things get a lot more uncertain. And this is where you need to do a lot of computational or simulation-based physics, which is a little bit outside my wheelhouse, but I can give some examples of some other objects that we have seen recently. Most people remember there's an asteroid that passed over Russia in 2013, and this asteroid was about 22 meters across, or 1/500th of the diameter of Halley's Comet. And due to the rapid heating that these objects experience when they hit the atmosphere, this object detonated in what we call an air blast. So the superheating of the asteroid causes it to blow apart and even partially vaporize. Of course, there's a lot of energy associated with that air blast. The asteroid that passed over Russia detonated with the energy of about 30 times that of the nuclear bomb that detonated over Hiroshima. As soon as you start scaling that up, say 500 times larger for Halley's Comet, things start getting very cataclysmic very, very quickly. Even just the amount of heat energy as a comet would be passing through the atmosphere would throw off would be catastrophic. You'd even get weird effects from that heat that's beyond any sort of dust cloud on impact. You'd actually burn off a lot of the ozone layer from that heating cycle, which is not something that you think about when you think asteroid impact. You think of other things, but if you burn off that much of the ozone layer, it would take a very, very long time to recover that.
So the near miss, you're doing good, but once you get into the atmosphere, a lot of things could end up going wrong, even if it didn't end up plopping straight into the Atlantic Ocean.
Certainly. As soon as you start messing with the atmosphere, you now have the atmosphere, which can serve as really a medium to carry these shock waves, to carry the heat, to carry the energy. Whereas if it stays in space, space is to most good degrees, it's a very good vacuum, and therefore a very good insulator of really all the chaos that such a flyby would create.
And what about that worst case scenario? It plops right down in the middle of the Atlantic. What would we expect?
I was reading into this, and there seem to be a couple conflicting studies. So some studies claim, yes, classic situation. You throw a rock in a pond, you get waves. You throw a comet in the ocean, you're going to get massive tidal waves. Others actually pointed out that if it impacts at such high speed and with such high temperature, you might actually get most of the water shooting back upwards and or being vaporized, which might not actually cause as large of a tidal wave as we might think. It'd be a big injection of energy, but not necessarily a large offset in the height of the water. It's like you would get in an earthquake with a tectonic plate shift. It's sort of an interesting idea that some groups have put forward that an asteroid plummeting into the ocean in terms of tidal wave effects might not actually do that much. It's the amount of energy that's releasing as it goes through the atmosphere that would really be the terrifying bit. And this is an object that'd be moving at many thousand times the speed of sound. The sonic boom alone from it would be insane. You'd have it superheating itself as it did. So you have rock, snow, ice, even other chemicals like frozen CO2 and ammonia vaporizing off it. It would be quite spectacular. It would certainly cause damage to the atmosphere, damage to the ozone layer. But depending on how far away from civilization you put it, it might not be as catastrophic as most people think. Of course, all of this is a lot of speculation. We haven't seen it, but we can run a lot of computer-based models to try to test out what this would look like. Of course, at energies this high, models start to break down because most computers and most models aren't designed to deal with things traveling at thousands of times the speed of sound with this much energy. It's certainly an interesting area of study.
A generation ago, we had Armageddon and Deep Impact, but decades before that, they had the Blue Comet, a look at a comet on a collision course with Earth and the societal and interpersonal disruptions that we would have. Anthony, really appreciate you taking the time to talk through the fact and the fiction of this fun little sci-fi comedy. Is there anything else that you'd like to mention about your areas of study and interest in research when you're not looking through the truth and fiction of the Blue Comet?
A lot of my work right now actually doesn't involve asteroids anymore. Instead, I work on some of the very first and oldest galaxies. So these are galaxies that are very, very rare, very hard to find. So I use very wide areas of the night sky in imaging, using some of the telescopes like the Subaru telescope out in Hawaii on Mauna Kea. And we try to look at large images of the sky in multiple different colors and filters. And from that, I can try to find some of these objects that I think are some of these very old, very bright galaxies. I then go back using some different telescopes out in Hawaii, the Keck telescopes, and take the light from these objects, run it through a prism, and from there I can see exactly how much light in certain wavelengths and frequencies of light these objects emit. And from that signature, or the spectrum, I can tell certain chemical properties about these objects, including also getting to guess at what their age is and what the surrounding environment's like. So I'd say a lot of data-driven research, but also a lot of observation-driven research. And I love what I do here at UW-Madison, and it's hard to believe I've only got a year left.
Well, I really appreciate you taking the time. The national premiere of the Blue Comet will be August 23rd at 7 p.m. You can find location information at falconbridgeplayers.org. It's also on Eventbrite. Hope that everybody listening will join us for that. Anthony, thank you so much for your insights.
Thank you. The pleasure's all mine.